So you do remember Kf multiplied alpha 4 is a conditional constant. So the conditional constant will condition to the total EDTA, right? So it will be expressed like this, or you can put the alpha 4 down here to multiply that. It's the same thing as a y4 minus. Okay, so either way, whatever the way, is easier for you to see the picture. Okay, so this is the expression. Now, here is the deal for Chris and Lo. Now, this is your complex, right? The reverse arrow is going to give back a little bit of calcium 2 plus. Simultaneously, it's going to give you the Y4 minus. Yet, depends on the pH. This Y4 minus is going to associate with 1 proton, or 2, or 3, or 4. So, they come from initially 1 to 1, but this one is going to distribute into all that. Okay, so all that becomes Cy. Okay, all this is Cy, and you want to see within the Cy what is a fraction of that to the total, because only this guy is going to incorporate into the K expression. Okay, so now you understand the picture. Alpha 4 comes in to determine, this Cy total, what fraction belongs to Y4 minus. Now, because the setup is like this, right? So the Cy and calcium 2 plus. Now, this total is equal to this total, right? Isn't it? They come from the same complex. They have to be equal, right? So this is X, then this is also X. They come from initially the same one complex, for example, okay? So now X is equal to Cy X. And we are solving for calcium 2 plus, so conveniently, just call this X squared. Okay, so this is squared. So the rest is just calculation. So you get the total complex with a little bit dissociate the minus X. So here you generate 0 plus X. So it's X squared. So this is negligible. And you solve the X. The X is equal to 10 to the minus 7. So the assumption is valid, right? This is 10 to the minus 7, and here 10 to the minus 7, then it's indeed negligible. So now you can get the P calcium at the end point, right? Yeah.
What did you do to determine whether the X is negligible before calculating for it? Or how did you determine that?
Initially, you look at the Kf, because the Kf is so large. Just like your Ka value is the reverse, small, you take the square root. And here, you may do the same thing. Because of reverse, you can look at it as a 10 to the minus 10. Okay, take square root roughly. So it's equal to about 10 to the minus 10 or so. If you take a square root of that. So even 10 to the minus 5, then it is 100 times. So it's negligible. So make that assumption first, and then calculate, and indeed it's negligible. If you made the wrong assumption, then this number will show up that, hey, you made a wrong assumption. You need to do quadratic equation. Then you go back.
So you take the square root of the Kf, and because the Kf are 10 to the 10, you do
10 to the 10.
10 to the 5.
And we are talking about a reverse reaction.
So it'd be
10 to the minus.
So that makes it 10 minus 5.
Yeah.
Okay.
Yeah, square root of that, because of square later on, square. Yeah, so that is the endpoint pH. P calcium. Now, beyond the endpoint, we understand we have excess EDTA, right? So, you understand that, the total EDTA is equal to the complex and those not complex. So now, what about at equilibrium, the excess, the not complex, right? Total is equal to the total EDTA that you add minus those react with all the calcium to form the complex, right? So the total here, as you can envision, so 7.5 mil EDTA all added in, subtract the limiting amount of calcium to form the complex, right? This is how we form the complex. So the difference between the two is the quantity that is left behind for all the EDTA species, right? Okay, so the complex is like that, simply based on the limiting agent. Now it's a dilution. Dilution compared to previous one, at the end point. So your concentration is somewhat lower. So this is one tricky question, dilution. Some people forget. They thought that I just carry the concentration from the previous answer for at the end point would be right. But then here is a different condition, you have a dilution. So a little lower concentration. Okay, so now you calculate for the free calcium, then from the expression that this is at equilibrium, the complex is right up here. Then the total amounts of excess EDTA, right, is up here. We just calculated it, right? The excess 4.5. So there's a CY. So CY multiply alpha 4 is equal to your Y minus 4. But here we use CY and put the alpha 4 to the left. Same thing. So leaving behind just one unknown calcium that you solve for, right? So you end up with such a tiny number, very tiny, because of excess EDTA in it. Stabilize the product, okay, when you have excess EDTA. So this is P calcium. And for your homework is this. Okay, see you later. Well, Anton is taking a picture of that, but not a picture of me. I'm a fan.
Soccer.